In this video, we will be seeing how to find the longest consecutive sequence in the input array and also compute the time complexity and space complexity of the solution that we will be building, and we will be using JavaScript to build a solution. Before jumping into the solution aspect of it, let's first try to get an understanding of what the problem statement is. Given an input array something like this, 10, 4, 200, 1, 3, 2, we have to find the number of the longest consecutive sequence. What does consecutive sequence mean? Let's say you have 1, you add 1 to it, you get 2. 2, you add 1 to it, you get 3. Now this is a consecutive sequence. To your current element, if you add 1 and then you get your next element, this is a consecutive sequence. Now to this element you again add 1 and you get the next element, which is 3. This is still consecutive. Now let's say you have 5 here. This is no longer consecutive. So you will just have this 3 as consecutive sequence, and there are 3 elements, so it will mean it is 3. Now in this example, if I see that these elements are jumbled, they are not sorted. So that's going to be the constraint that we are going to be having to deal with in our problem statement, is that your array is not going to be sorted. And as I drive to this array, I see we have, I will start from the lowest. We have 1 here. After 1 we have 2. After 2 we have 3. After 3 we have 4. So 1, 2, 3, 4, which has 4 elements. That means the output is 4. That is the basic core of the problem statement. And we will first try to build a solution using brute force and then try to optimize it to see how we can improve the time complexity that is going to be involved. The core idea of our solution is going to be that we're going to pick an element. So we will be iterating through this array. And let's say I pick 1 for the sake of simplicity. You will pick this one, and then for this one I will try to find a consecutive sequence. So I will try to say 1 plus 1, which is 2. I will try to see, hey, does this 2 exist in my array? So this is my array. I will try to find in this array my 2. If it exists, I will just increment by counter of my sequence by 1. Similarly to this 2, then I will add a 1 and I will say this is 3. I will say, hey, do you have 3 in your array? In our case we have this 3. All good. We will again increment the counter. So we started with counter as 1, then we made it 2, and then plus 1 we made it 3 in the sequence. And then I will add another 1 to this, which is 4, and I will say increment my counter again, which is now 4, and I will say do the same thing again, add 1 to it, which is 5. I will say, hey, do you have 5 in the array? You don't have 5 in this input array. That means my sequence ends. So I will just consider this as my sequence. I will maintain a counter, and that counter is going to be my current consecutive sequence. This is just an example, considering that we started at one element, this element, and then we just iterated through our input that we had to try to find the next number. This thing is something which will translate into code as a loop. So first you will have one loop that is going to be iterating through all your elements, and then to do this part we will have another loop that will just keep on checking by adding 1 to your current element if you have it in your input array. If you have it, you just keep on incrementing the sequence, then you take that element, you just add 1 to it, again keep on incrementing the sequence, and keep repeating this until you have met the exit criteria, which is after doing plus 1 you try to find the next consecutive element in your array, and if it doesn't exist you just exit the loop. That's the basic functionality. and this will translate into code into something like this. So let's say I want to find a consecutive sequence. I will say initially it's just 0, and at the end what I'm going to do is just return my consecutive sequence, which I will build into this logic part. And we said we will need a loop to iterate through all our elements that we have. So the first loop will be for let I 0, I is less than nums dot length I plus plus. You just iterate through your input that you have. And now comes the part of keeping your own tracker. So what we will say is, I will start with this element that is going to be my current element. So let current number is going to be my nums of I. After having this as my current, if you just have this number in your array, this is going to be translating into saying that I just have one element in my current sequence so far. So that will just reflect into something like this. So current consecutive sequence is going to be 1, because if you just have one element that you are currently considering, that will mean that the length of your consecutive sequence is also 1, technically speaking. And I will take this as my base case now, which is here, and then I want to keep on adding 1 to it as long as it satisfies my consecutive number criteria. And what that will be is while my criteria is getting satisfied. Now what is this criteria? You have your current number, let's say it is 1. This current number plus 1 has to be in your input array. So we said we did 1 plus 1, which is 2. Find 2 in your input array. If you find 2, increment the counter and then continue. So I will say nums dot includes my current element plus 1. If this criteria is being satisfied, only then I will increase my sequence, and then to keep the loop running, in the sense that you started with 1, you added 1 to it, and you got 2. 2 is there in your array, then you want to have this as your current number now, and then keep on adding 1 to it to again check if the next element in the sequence, which is 3, will exist in the array or not. So this is while the condition is getting satisfied, you increment your current number. So from 1 now it will become 2, which is here, and then you also increment your sequence. So because you now have 2 elements in your sequence, 1 and 2, and you keep doing this until your exit condition, and after your exit condition is reached, you will have some sequence, which is going to be this current sequence that you have. And after the loop ends, we have to just compare it with our main final solution that we are going to be returning. So we just compare this number that we have in our current sequence with a final sequence tracker that we have. We will find all the subsequences in our input array, and they all might not be the longest. We have to find the longest one. That's why we just do this math.max here to find the longest sequence. And that's pretty much it. You just have this outer loop here, then you run an inner loop, and then after the loop ends, you just say here that find the max, and then return after your outer loop runs whatever final value you have. Now in terms of time complexity, there are still things we can improve here. What can be improved? The time complexity of this outer loop is going to be big O of n, because it runs through the entire length of your input. So if you have n inputs, that will mean the time complexity is also going to be order of n. Next, after this, you have another while loop here. So that while loop is just running and saying current element plus 1, current element plus 1, condition getting satisfied, you keep running it. So this will also have time complexity of order of n in the worst case. And also we have this includes, which checks the entire array to see if you have your current element in the array or not. This is also going to have a time complexity of order of n, and that will lead to order of n to the whole cube, because this, then you have this nested here, and then you have this one here. So you have 3 levels, and that's why the time complexity will be big O of n to the power of 3. Now this is not so great. You will be running this program with this time complexity. It will most probably exceed the time limits in your test cases that you try to run. So we will now try to improve this step by step. Now let's start from inside here. So we said inside this while loop you have this nums dot includes, and this is going to take up order of n time complexity to search in the entire list that we have, the lookup time. Now we can reduce this lookup time by using a data structure that JavaScript provides, that is a set, because the lookup inside a set will be big O of 1 time complexity. So what we can do is, let's introduce a set. We can say tracker set is equal to new set, and inside this set we'll put all our elements that we have. So it will just go uniquely inside this set, giving us a lookup time of time complexity of big O of 1. Now after doing this, instead of checking inside the array if the element exists, we will just say whether the set has this element or not, and that will immediately bring our time complexity down to big O of n square. So from this we can get it to n square. Now big O of n square is still not so great. Let's try to go a step further and try to see if we can improve it even further. So what we can try to improve it to? We said this runs in order of n, and this also runs in order of n. If you start here and then keep on running through the entire elements, then it is order of n as well inside. So order of n and then order of n, which becomes order of n square. But what if I try to restrict this internal loop that I run to only certain elements? What I want to do here is to restrict the inner loop only to a certain set of elements. I will try to say what are the elements that I want to restrict them to. Can I put some checks in place to make sure that I only count it from the start of my sequence that I have? What I mean by that is, if the tracker set that you are keeping doesn't have the element -1. So what I mean to say is, you have 1 here and you have 2 here. Now in a tracker set, I will just say 1, 2, 3 and 4. As soon as you initialize this set, you are putting all these elements into my set here inside the data structure. Now let's say I was here and I say 2 minus 1, which is 1. This already exists in my set. So in my previous iteration, if I was here, I would have done tracker has current plus 1, which is 2, and have reached to the next element in my loop. That means I have already traversed it. If the current element minus the previous element already existed in my set. That means that if it is there, then it is not the start of my sequence. There would already be some other element in the sequence that we have, and that will translate into something like this. So the main aim here is to ensure that when you are doing this repeated checks of this loop, because please note that we said we will iterate through all the elements. That is this outer loop. So you will go through 4 and then try to go through all these elements. You will go through 1 and go through all the elements. You will go through 2 again, and then you will go through 3, 4 also again, inside this nested loop, and that will form repeated patterns. So basically you will go from 1 to 2 to 3 to 4. From 2 you will go to 3 to 4. So you see some repetitions are happening here, and I want to make sure that only if it is the start of my sequence, then only do this iteration that is the inner iteration. And I said here, if my current element -1, which is 1 in this case, already existed in the set, that means the sequence has been repeated again. And if it doesn't, that will mean that it is the start of my sequence. What I mean to say is, you have 1 here. 1 minus 1 is 0. You don't have 0 in this set, and that means that this is the start of a sequence from 1. And what we can say is, if inside this outer loop some kind of start of the sequence check, if we are able to put, then we can reduce this time complexity from big of n that is currently traversing through the entire length of the array. And what we can say here is, if tracker set doesn't have my previous element, now my previous element is just going to be my current element, which is going to be this nums of I, which is here. And I will say, if tracker doesn't have this element, then only do this, which is what we covered here. If it has, that means you have already covered the sequence with a previous number, and you are just repeating the same pattern. So what we will do is, entire thing that we have in terms of checks, we will just put inside our if condition. So this will just go here, and we will say just move the tracker here and move the tracker here, and yep, like this. So now we said that if you have not already encountered that element as part of another sequence, because we said we will keep on going through all the elements using our outer loop, then this will reduce the time complexity from big O of n square to this outer element having the time complexity of big O of n. And initially this was also big O of n, and both of them were getting combined to form big O of n square. But now, because we put this checks in place, this is not going to execute always. So it will become big O of n plus n, which is big O of n itself. And that's pretty much it.